Hi students, welcome to this video session. I remain Samuel Chukwu Emeka, aka Sam Dump for Peace. In this video session, we shall continue our study on arguments. In this video session, we shall discuss the standard forms of invalid arguments. Please, before you continue with this video, it is highly recommended that you have viewed the video on standard forms of valid arguments before you view this video. In addition, it is very important that you view the videos in order. The videos in the playlist, you need to view those videos in order. The playlist is on my website, and the playlist is logic and truth tables. Please view those videos in order. So today we shall look at standard forms of invalid arguments. Standard forms of invalid arguments. In the previous video prior to this one, the video immediately preceding this one, we say that invalid arguments is known as a fallacy. Okay, fallacies. An invalid argument is also known as fallacy. An invalid argument is also known as fallacy. And we say that it's an argument that is not valid. Okay, it is not valid. The conclusion does not necessarily follow from the premises. And in that previous video, I taught you a way that you could easily tell which ones are valid forms and which ones are not. So we shall also use that technique here in this video. So recall that when we had the conditional statement is P implies Q. If P, then Q. And then the converse would be what? If Q, then P. The inverse would be if not P, then not Q. And then the contrapositive is if not Q, then not P. So we dealt with these two in the previous video. Valid arguments, we dealt with these two. So tonight we are going to look at these two and other forms as well. So and with I showed you a way that you could find out. So the first form we are going to talk about is what we call fallacy of the converse. Fallacy of the converse. Fallacy of the converse. That will be the first one we will talk about as an invalid argument. And we said that this will be P implies Q, then you now have Q, therefore P. So you see, just like we mentioned in the previous video, you see the way this goes here. Okay? This of course is premise 1. This is premise 1. This is premise 2. And then this is the conclusion. So you see the way that goes. That was the technique we used in the previous video. And we are still using that technique here. So this is known as fallacy of the converse. So even without writing fallacy of the inverse, you should kind of tell me what it will look like. Right? For fallacy of the inverse, of course, the premise one will be the same. P implies Q, or if P then Q. Then for premise 2, you would now have not P, and then the conclusion you now have not Q. So that technique, to make you to remember, in case your professor does not provide it for you. Okay, so let us verify this. Let us verify the invalidity of the arguments using the two methods we talked about in the previous video. So let's use the first method, okay? And the first method is what we call by formula and truth tables. So this will be that premise 1, which is P implies Q, and premise 2, Q, then implies conclusion P. So let us draw the truth table for this. So we have P, we have Q, we have P implies Q, we have P implies Q, and Q, and Q, and then we now have P implies Q, and Q implies P. Okay? As usual, I use two lines to demarcate it. Then this will be true, true, false, false. And this will be true, false, true, false. So this true implies true is true, true implies false is false, false implies true, true, false implies false, true. Then true and true is true, false and false is false, true and true is true, true and false is false. Then true implies true here is true, false implies true is true, true implies false here is false, false implies false, true. So because you have, this is not a tautology, okay, this is not a tautology, this is a contingency, okay, this is not a tautology, not a tautology. So therefore, argument is invalid. Argument is invalid. So that is the fallacy of the converse. So we just verify the invalidity using the first method. Now let us use the second method to verify the invalidity. And with the second method, we check the premise 1, premise 2, and conclusion. That is all we need. And we see already that it is here. So what I'm going to do, I'm going to write premise 1 here. This is premise 1. And then I will write premise 2. This is premise 2 here. Premise 2. And then this is my conclusion here. Conclusion. Okay? So I don't need this. I do not need this. From here, I don't need it. For the second method. So we check the cases. Let's check the cases whereby the two premises are true. We see this is one case here. One case here. The two premises are true. This is another case here. The two premises are true. In this case, the conclusion is true, so this passed the test. But here, the conclusion is false. And because this is false, the argument is invalid. Invalid argument. Remember, when we talked about this second method in the previous video, we said that if you have two premises that are true, you must have a conclusion that is true. When you have two premises that are true and you have a conclusion that is false, the argument is invalid. If there is any case whereby, if you're using the second method, okay, if there is any case whereby you have two premises that are true and you have a conclusion that is false, that makes the argument invalid. Okay, so this is what we call fallacy of the converse. Okay, now let us go to fallacy of the inverse. Fallacy of the inverse. So, I am thinking that you already know what fallacy of the inverse will be. I mean, from what we have discussed so far. So, can you pause the video and write it, and then let us see whether we get the same thing. Okay. The second one, fallacy of the inverse. Fallacy of the inverse. So, fallacy of the inverse, what is the premise one? The premise one will be P implies Q. That will be the premise one. Premise two, what do you think the premise two will be from here? Not P. Not P. I mean, without memorizing this, you just understand it. No? Therefore, conclusion, therefore not Q, not Q. And this is the way it goes here. If you follow the method that we talked about in the previous video, that is the way. Okay, so the next thing for us to do now is to use those two methods to determine that it is invalid. So let's use the first method, premise 1, which is P implies Q, and premise 2, not P, then implies conclusion, not Q. Okay, let's draw the truth table for this. So we have premise, we have P, we have Q, we have P implies Q, we have not P, we have P implies Q and not P, okay, then we have not Q, and then the last one we have P implies Q and not P, okay, implies not Q. Not Q. So I use double lines to demarcate it like I do, unique to me. So I have true, true, false, false, and here I have true, false, true, false. So true implies true is true, true implies false is false, false implies true is true, false implies false is true. Okay? Not P, not true is false, false, not false is true, true. Then true and false is false, false and false is false, true and true is true, true and true is true. Not Q, not true is false, not false is true, not true is false, not false is true. Okay, then false implies false is true, false implies true is true, true implies false is false, true implies true is true. So because we have false here, it is not a tautology. Not a tautology, argument is invalid. It is a contingency, okay? Not a tautology, therefore argument is invalid. Invalid argument. Or you say argument is invalid. So anytime we are asked to analyze an argument, the first thing we want to do is to check whether we put it in symbolic form, which is what we call symbolic arguments, and we check whether it corresponds to any of the valid forms or invalid forms. Okay, if it does, then it makes our work simpler. If it does not, then we use any of the two methods I taught in the previous video to determine the validity or invalidity of the argument. Okay. Okay, so this is the first method. Now let's use the second method to determine that this argument is invalid. With the second method, let me write the premise. Premise 1, this is premise 1. And this is premise 2. Premise 2. And the conclusion is this. This is the conclusion here. So I don't need the rest of the thing. I don't need it. So let me go ahead and erase it. I don't need this one. And I don't need this for second method. Okay, then I check the cases. I'm only interested in the cases whereby the two premises are true. That is what I am interested in. So I have this case here, and I have this case here. Okay, in this case, the conclusion is false. No. Even though this one is true, but here the conclusion is false. Once I have any case at all, in which the two premises that are true gives a conclusion that is false, the argument is invalid. Invalid argument. Invalid argument. Okay? Comprenez-vous? Alright. Let's go to the other ones. We have two more. Okay? Just like we have in the previous one. So we are done with this conditional, converse, inverse. Let's now look at the third one. In the valid arguments, we talked about the disjunctive reasoning, right? We talked about the disjunctive reasoning. For valid arguments, we say that disjunctive reasoning is P or Q, right? And then not P, therefore Q. And we also said you could have P or Q, not Q, therefore P. This is a valid argument. Disjunctive reasoning. Or you can say disjunctive syllogism. Right? Okay. Now we have the third one. The third one is misuse of the disjunctive reasoning. Misuse of the disjunctive reasoning. And I'm going to show you the trick of this one. Or you can say misuse of disjunctive syllogism. Misuse of disjunctive reasoning. Okay? So, in this case, some people will misuse it. You know, this is a valid argument. Of course, if it is P or Q, okay, if it is either the color is red or the car is blue. Or, remember when we talked of or. Well, the color is not red. Okay, therefore the car is blue. Or you can say, well, the car is not blue. Therefore the color is red. Alright. See the misuse here. You could have P or Q, and then you now have P, therefore not Q. This is a misuse for this one. Instead of putting not P, therefore Q, okay, you put P, therefore not Q. That is, you now negate this Q instead of negating P. Now, if you say the color is red or the car is blue, well, the color is red, therefore the car is not blue. Check the reasoning. Does it make sense? You say the color is red or the car is blue. Well, the color is red. And you now say, therefore, the car is not blue. Okay? That doesn't make sense. Now, and then another misuse is when you have P or Q and you have Q, therefore not P. These are the two forms here that are invalid. Okay, so the next thing we have to do is to do what? Determine the invalidity. Determine the invalidity. Let's determine the invalidity. Okay? So, for this one, for the first one, we have, and let's just do everything together. Okay, let's do everything together once that's in a big one. So, like for this one, for this particular one, we have, for the first method, premise 1 and premise 2 implies conclusion. That's for this one. And then for this one, we have premise 1 and premise 2 implies conclusion. For the first one, it is P or Q, and P implies not Q. For the second one, it is P or Q, and Q implies not P. So let's kind of have everything in the table. The truth table, we have P. Let me start from here so I have space. So we have P, we have Q, we have P or Q, okay? We have P or Q and P, okay? We have not Q. We have P or Q and P implies not Q. So we need this column here. We need this column here for the first form. Okay, these are still, anytime you have it in these two forms, it's still misuse of disjunctive reasoning. The argument is invalid, which we want to show you how it is invalid. Then, next one we have P or Q, and if you want me to use a line to demarcate here, that's fine. P or Q and Q, that is if you want to. Okay? And if you want to put something here, because some people might say, why don't you put something? That's okay, if you want to do that. Then we now have not P, and then we have P or Q, and Q implies not P. So it kind of saves us time if we have just one table. So we can show it. And we are interested in this one for the second form of the same invalid argument. So we have true, false, false. And then here we have true, false, okay? True or true is true or false, false or true, false or false, false. Remember, this is disjunction, or. Then, true and, this is conjunction now. True and true is true and true is true and false is false, false and false is false. Then not Q, not true is false, not false is true, not true is false, not false is true. Okay? Then true implies false is what? False. True implies true is true. False implies false is true. False implies true is true. So because we have, this is not a tautology. Not a tautology. Invalid argument. Invalid argument. It's not a tautology. Then here we have true and true is true. True and false is false. True and true is true. False and false is false. Okay? Then not P, not true is false, not true is false, not false is true, not false is true. True implies false is false, false implies false, true, true implies true, true, false implies true, true. So the same thing, invalid argument. You see, both of them are invalid. And both of them are equivalent because they have false, true, true, true. False, true, true, true. False, true, true, true. Both of them are equivalent statements because they have the same truth values in their final column of the truth tables. They have the same truth values in the final column of their truth tables. So they are equivalent, what we call equivalent statements. Okay, so it's invalid argument. Now this is the first method. Let us now use the second method. Okay, with the second method, let's identify the premises. In this one, the premise, this is premise 1, premise 1, premise 2 here, and then conclusion is this conclusion. Now let me use another color for this second form. Premise 1 will be this one also, premise 1. Premise 2 will be Q, premise 2, and then conclusion will be not P, conclusion. So let me erase what I don't need so that it doesn't distract me. So I'm using the second method. I just erase what I do not need. Okay, I don't need this one. And I don't need this one. All right. Now, let's start with the first form. So let's check the case where the two premises are true. This one, I'm gonna still use red for this. So this case here, the two premises are true. Then this case also, the two premises are true. So we have two cases whereby the two premises are true. Okay? And now let's check the conclusion for those. This has a false conclusion, so this is no. Even though this one is okay, but this is no. So that means the argument is invalid. Now let's do that for the second one, the second form here. In this case, the two premises are true. And also here, the two premises are true. I used another color. Then let's check the conclusion for those. Conclusion for this one is still false, so this is wrong. Even though the conclusion for this is true. But this is false. Invalid argument. Does that make sense? Okay, let's look at the fourth one, the fourth form of invalid arguments. The fourth form of invalid arguments. And who can tell me the fourth form? at least from the valid arguments, you could tell what should be the fourth form, and that should be misuse of what? Transitive reasoning. Misuse of transitive reasoning. So remember, when we did the valid arguments, we said that transitive reasoning, okay, or what you call syllogism or transitive reasoning. We say we have premise 1, P implies Q, premise 2, Q implies R, therefore P implies R. This is a valid argument. Okay? And we also say that because this is conditional, because the conditional and the contrapositive are equivalent, you could still have this and it will work. You could still have not R implies not P, and it should still work. Okay, so when you have something like this, P implies Q, Q implies R, and then not R, therefore not R implies not P. It's still valid forms under transitive reasoning. Okay, now look at the misuse here. The misuse of the transitive reasoning is P implies Q, premise 1, let's write premise 1, P implies Q. Premise 2, Q implies R. So what do you think will be the conclusion? Conclusion will be, instead of P implies R, it will be R implies P. That is the misuse. Okay? And because the conditional and contrapositive, what is the contrapositive of this? Not P implies not R. Implies not R. So when you also have it like this, if you also have it like this, P implies Q, Q implies R, therefore not P implies not R. It's still a invalid argument by misuse of transitive reasoning. Okay? So, like this is the main one, but you know that this and this are equivalent. So, it could still work in both cases as invalid arguments. Alright, so let's use the two methods to determine that it is invalid. Okay? To determine that it is invalid. Let's use both methods, two methods to do that. The first method, we see that premise 1, P implies Q, and premise 2, Q implies R, implies conclusion, R implies P. Okay, so we have a P, we have P, we have Q, we have R, we have P implies Q, we have Q implies R, we have P implies Q, and Q implies R. Then we have R implies P, and then we have P implies Q, and Q implies R, implies R implies P. All right. So I use my double lines as usual. So I have true true, true, false, 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 false. True, 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 false, 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 false. Q will be true, true, false, false, true, true, false, false. Arrow will be true, false, true, false, true, false, true, false. Okay? P implies Q. True implies true is true, 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 false, false, true, false, 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 true, true, false, true, true, false, false, true, false, false, true. Okay? Implication. Conditional statement. Q implies arrow. True implies true, true, true implies false, 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 true, true, false, false, true, 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 false, 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 true, true, false, false, true. Okay? Q implies arrow. Let's check it again. True, true, false, false, true, 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 true. True, false, true, 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 false, true, true. Okay, and this, true and true, true, true and false, false, false and true, false, false, true, false, true, 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 false, false, true, 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 true. Okay? You with me? Are you with me? I am double checking it as well to make sure I get it right, you know, because I don't want to mess up. Okay. Okay, I think it's so far so good. Now, R implies P. True implies true is true. Yeah. False implies true is true. True, true, true. False, true, true. True, false is false. False, false, true. True, false, false. Okay. True, true, true. False, true, true. True, true, true. False, true, true. True, false, false. False, false, true. True, false, false. False, false, true. Okay? Now this implies this. True implies true is true. False implies true, true. False implies true, true. False implies true, true. True implies false is false. False implies true, true. True implies false, false. True implies true, true. So this is a contingency. It is not a tautology. So argument is invalid. Okay? Argument is invalid. Not a tautology. Argument is invalid. And you know, if you do it with the equivalent statement there, you will still get the same truth values in the final column. Because this conditional and this contrapositive are equivalent. You view the videos we did in the playlist. We did variations of the conditional statements. Okay? We have shown that it is invalid using the first method. Let us use the second method. So, let me write my premises. I have this as premise 1. Premise 1. I have this as premise 2. Okay? And then R implies P is my conclusion. Okay, let me just erase what I don't need. I don't need this. I erase it. And I don't need this. I erase it. cases whereby both premises are true. So I have this case here, true, 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 false, no, false, true, no, false, true, no, true, true here. I have this case, true, false, no, true, true here. I have this case. And then I have this case. 4 cases whereby the premises are true. 4 cases. Okay? Now let me check the conclusion on in each case. If I see any case, even one case, whereby the conclusion is false, it makes it an invalid argument. Okay? So this is true, this works. This one is true, it works. 1, 2. Now wait a minute. This is, okay, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this is false. This one is false. No. Makes it an invalid argument right away. We don't care what others is. And this is also false, and this is also true. So but this true, one of them alone makes it an invalid argument. Argument is invalid. Invalid argument. Okay, so we have demonstrated how you could know the standard forms of valid arguments and the standard forms of invalid arguments. Assuming your professor does not give you those forms, at least you now know how to know them. Okay, so in the subsequent videos we shall do under arguments, when they give us an argument to analyze, the first thing we have to do is check, put it, if they give it to us in English, like I mentioned in the previous video, we will analyze some arguments from politicians in debates. When they debate, some of their statements could be put as an argument, and also some in the law court. So when we do that, and other statements, other logical statements, we will analyze it. The first thing we'll do is we put it in symbolic logic. Okay, we write those statements as logical symbols. Then after that, we will check whether it conforms to any of those forms, whether it conforms to the valid forms of valid arguments or forms of invalid arguments. If it does, we just say this argument is invalid due to fallacy of the inverse. We could say this argument is valid due to modus tollens. Okay? We just state, okay, this argument is valid or invalid due to this. If it does not correspond to any of the forms of valid or invalid arguments, then we shall use the 2 methods we illustrated. Okay, the first method is by formula and truth tables, and the second method is by definition. So we use any of those 2 methods. We shall use both methods. Like I said, I would encourage you to learn both methods. Use one to solve it, use the other one to check it. Okay, so hang in there for tonight. We're done with this. Okay, if you have any questions, please feel free to ask. Thank you for listening.
You have a great